The fourth question that we have is a very conceptual problem. We have been given an equation of a moving pulse. We need to find out which statements of these are true. The first one is the pulse is moving in the plus x direction. So whenever there is talk of the direction of the pulse or the wave, we try to find out the velocity of the pulse. So for finding out the velocity, we'll find out all those y. We'll find all those points for which y is same. For that, y has to be constant. Therefore, for that, this thing has to be constant. Therefore, for that, 4x plus 5t is equal to constant. Or rather, you just, for future, just take the term which is variable and put that equal to constant to get the velocity. Then differentiated this with respect to t. So we get 4 dx by dt plus 5 is equal to 0. Therefore, dx by dt, that is equal to velocity of the wave or the pulse in this case, will be equal to minus 5 by 4. So the pulse speed is coming out to be negative, therefore the pulse is moving in the negative x direction. Therefore, the first statement is false. As for the second part, in 2 seconds it will travel a distance of, we'll just multiply it by minus 5 by 4 into 2. We need to find out the distance, so we remove the minus sign, it becomes 2.5 meters. So second part is true. As for the third part, we need to find out the maximum displacement. The maximum displacement means the highest or the maximum y coordinate that any particle reaches. So for this to be maximum, this denominator has to be minimum. Now for this denominator to be minimum, this has to be minimum. Now since this is whole square, this is a positive quantity, therefore the minimum value of this quantity can be 0. And we have to now check whether that 0 is achievable or not. It is. Why? Because for some combination of x and t, we can obviously get the value of this term to be equal to 0. So for that value of x and t for which this becomes 0, the value of displacement becomes equal to 0.8 upon 5, that is equal to 0.16 meters, and therefore the C option is also true. Now the fourth part is that it is claiming that the pulse is symmetric in nature. So let's check it out from this equation again. So in this chapter you just have to be very careful in analyzing the equations. So in this part we see that this is an equation, this is a term is quadratic in nature. Now since it is quadratic in nature, let us check for any time t. For any fixed time t, this will be some quadratic equation. Therefore, since this is some quadratic equation, we know that the graph of a quadratic equation is always symmetric about this axis. Therefore, the graph, the denominator is always symmetric, that is, it will always have some values of x for which it will get same values, and these values of x will be at equal distance from this axis. So for these values of x, since the denominator is same, this whole term will also always be the same. Therefore, this will always be symmetric for any time t. Similarly, we can say for any x, this will be symmetric for different time intervals also. So therefore, this claim that the pulse is symmetric is also true. So we get the answer for a four parts as false, true, true and true.